Yeah, hello, welcome to our project execution. So let us see, as we know that we are doing a project on weather monitoring system. This is our block diagram where we need to take the data of sensors like temperature, pressure, wind, and rainfall, just like carbon dioxide and humidity, and send it to the cloud through Ethernet. As this is a process of cloud involved, so I'm calling this as an IOT, and I have used an IOT cloud over here called as thinkspeak. Let us see execution of this. So now our final output should be the sensors data has to be taken here. We have used ARM processor where we replace this with the Raspberry Pi, and then through Ethernet we are interconnecting to the cloud based on internet provided through Ethernet, and we can see the same on the PC or mobile device, as the cloud can be accessible for all the mobility systems. Okay, now we have discussed regarding the abstract and our project overview. Let us see this on the system, and here we can see here we are moving the data of sensors to ARM 7 and then ARM processor, and through that Ethernet. So if you doesn't have internet to your Ethernet, what about the monitoring section? So because the monitoring section PC and mobile devices are connected to the cloud, it has to be transferred to the internet. So let us see second scenario. In worst case where you doesn't have internet, you can directly view that through Ethernet in the PC over here. Think that is a server. The data which you are pushing into the cloud might be in the server. Let us see this. Up to now I think we have explained this block diagram. Let us see the physical sensors over here. So here is my setup, which consists of ARM 7, ARM 11, that is Raspberry Pi, made of Broadcom BCM2385, and this is just for getting alert of any sensor data increase with some threshold limit. I just used a buzzer. Let us see exactly what are the sensors we have used. As the parameters we had rain sensor, here we used a rain sensor, and to measure pressure, here we have used pressure sensor, and for maintaining for calibrating the carbon monoxide, here we used MQ7 carbon monoxide, and this is a airflow sensor, and for getting humidity HS04 is given over here, and also for getting temperature LM35 is given over here. So now all these sensors has been interfaced to Raspberry Pi. So as Raspberry Pi doesn't have internal ADC, and coming over MQ7 and this water flow sensor and temperature and humidity are four sensors which are analog sensors. So we have used here an analog to digital converter, that is TCF8591. This is an I2C based IC, so I just used I2C connection over here, and these two wires are the SDL and SCL pins, so which is given to Raspberry Pi, SCL and SCL. I'll show the block schematic in the later pic. And let us go with the digital sensors. So, and coming to piezo sensor and this rain sensors or digital sensor, so directly it is given to the Raspberry Pi. Next, as Raspberry Pi, the sensor data we are pushing into the cloud, we required internet for this. So I just used Ethernet supply for the Raspberry Pi. Let us see how Ethernet has to be connected. So now we'll see how to connect to the internet as we doesn't have modem over here, by using sharing. So first we will connect to our modem, that is Wi-Fi modem, as I doesn't have a Wi-Fi dongle, and just connecting the same, not to purchase of Wi-Fi dongle again. I can use sharing the internet using these things. So let us see how to make sharing of a network connected to your laptop. So here it asks you allow other networks of user to connect through this, and say some connection, provide the connection, and then say OK. Now we can see here the sharing is unplugged, and when we say OK, it gets connected. Now again we again require to set the properties over here, that is nothing but IPs. So I require to set the IPs in this way for my system. So these are the IPs which we have given in the Raspberry Pi, that is static IPs. Say OK, and then OK. After setting up, you can see it is connected, but as Raspberry Pi is so, and this is what the scenario. Let us plug in. So as we see in the first scenario is for just for cloud, if you doesn't have internet connection for your Raspberry Pi, then means if you doesn't get how to share or something, we will see how to make this monitoring at the as a server. Let us see. So now I am providing the power supply, and you can see here it gets booted up again, and now as we know that it is connected to our laptop. So here what we are doing is we are connecting it in as a remote desktop, nothing but using a software called as PuTTY. So let us go with the PuTTY. This is what the PuTTY, as you know that next we'll enter into that PuTTY through SSH. So as we have given the IP address of Raspberry Pi as 192.168.1.2, I am entering it and say open. Now you get a command prompt of Raspberry Pi, and provide the login and password credentials. So here I have set it, the username as Pi, and password as Raspberry. And let us see, this is a command prompt. So to open our script, so we have written a script which gives a continuous weather monitoring of sensors. So the script will be opening of the script will be like this. Means these are the commands we have to type. These are the commands we have to type for running the script. Sudo space python interrupt.py and say enter. So we will get a screen over there, weather monitoring, and the values of the pressure, temperature, humidity, smoke and rain and airflow. So just I have given a small GUI like format in command prompt itself, and you can see the pressure sensor continuously gets varies because I am applying pressure over here, and if the pressure crosses certain limit, you can see here a buzzer sound, and also temperature over here will be like that. And let us apply a rain on the rainfall sensor, so you can see rain detected. And also we can do even make the temperature increase and increase airflow. In this way we can do just apply particular limits at particular sensors, and then you can see values over there. So in this way we can execute even if you doesn't have cloud. You can see when you powered Raspberry Pi, it gets booted up by seeing the blinking of green LED, which indicates booting process of Raspberry. And we can see here all the sensors are active, even to make as we know that MQ7 sensor gets heated up, which indicates it gets active. Next, let us see whether it is connected. After some booting process, we can let us go again to the network connection, and here you can see it is connected. Unidentified network, that is a local area connection to, as we have shared from laptop, it is get connected. Now your Raspberry Pi is getting internet, and as we have made automatic updation for the cloud, let us see the data of these sensors in the cloud. Now let me open the cloud. So here I use a small cloud, that is thinkspeak. So I'm just going to the website. And coming over the thinkspeak, as we have an account, we have to go into that account. So this we have to create when we are developing, and so I'm going into my account. As thinkspeak is a cloud which consists of all the accounts data, so we need to go into the particular account data. So you can see I have typed my account number, where it opens, and this is a weather monitoring, where you can see many graphs like field 1 chart, which gives the humidity sensor data, and field 2 which gives the pressure sensor, and field 3 which gives rain sensor, so whether rainfall or not, and the field 4 smoke, that is CO, and the field 5 temperature, and field 6 airflow. What is the airflow level over there? Is it constant and varying? So you can see time to time updates over here. So we have made the program in such a way that it will update for every 10 seconds. In this way we can make a weather monitoring station, probably used in the can be used directly into the real world. So thanks for watching, and we can make this very simple, and just we require to download the source code which I provided, and then dump into the memory card of or the memory of the Raspberry Pi, and slot it. Thank you.